Replenishment at sea or underway. Replenishment is a method of transferring fuel, munitions, and stores from one ship to another while underway. History. Concept. Prior to underway replenishment, coaling stations were the only way to refuel ships far from home. The Royal Navy had an unparalleled global logistics network of coaling stations and the world's largest collier fleet. This capability allowed the Navy to project naval power around the world and far from home ports. This, however, had two disadvantages. The infrastructure was vulnerable to disruption or attack, and its use introduced a predictable pattern to naval operations that an enemy could exploit. Early attempts at refueling and restocking at sea had been made as far back as 1870, when HMS Captain of the Channel Squadron was resupplied with coal at a rate of 5 tons per hour. However, the speed was far too slow to be generally practicable, and calm weather was required to keep the neighboring ships together. Lieutenant Robert Lowry was the first to suggest the use of large-scale underway replenishment techniques in an 1883 paper to the think tank Royal United Services Institute. He argued that a successful system would provide a minimum rate of 20 tons per hour while the ships maintain a speed of 5 knots. His proposal was for transfer to be effected through watertight coal carriers suspended from a cable between the two ships. Although his concept was rejected by the Admiralty, the advantages of such a system were made apparent to strategists on both sides of the Atlantic. Over 20 submissions were made to the RN between 1888 to 90 alone. First trials. The main technical problem was ensuring a constant distance between the two ships throughout the process. According to a report from the Times, a French collier had been able to provision 2 warships with 200 tons of coal at a speed of 6 knots using a Templey transporter in 1898. The United States Navy also became interested in the potential of underway replenishment. Lacking a similar collier fleet and network of coaling stations, and embarking on a large naval expansion, the Navy began conducting experiments in 1899 with a system devised by Spencer Miller and the Lidgerwood Manufacturing Company of New York. His device kept a cable suspended between the two ships taut, with a quick-release hook that could travel up and down the line with the use of a winch. The first test of the device involved the collier Marcellus and battleship Massachusetts. The RN embarked on more extensive trials in 1901, and reached a speed of 19 tons per hour. To meet the requirement for a rate of at least 40 tons per hour, Miller implemented a series of further improvements, such as improving the maintenance of tension in the cable, allowing for heavier loads to be supported. Miller also collaborated with the British Templey Company, producing an enhanced version known as the Templey-Miller system. RN trials with this new system in 1902 achieved an unprecedented average rate of 47 tons per hour and a peak rate of 60 tons per hour. The Thames Iron Works and Shipbuilding Company also patented its express equipment, which delivered supplies to the broadside of the ship, instead of from the aft. The company offered the system to the Admiralty, claiming that it had achieved a rate of 150 tons per hour, but the offer was turned down. A Royal Navy engineer, Metcalfe, put forward an alternative system in 1903, where 2 cables were used, and the cable tension was maintained with the use of a steam ram. Trials were held in 1903, which demonstrated an optimal operating speed of 10 knots with a transfer rate of 54 mph. Although it was a superior system and met with a formal endorsement from the Admiralty, there is little evidence that such equipment was ultimately put to any operational use by any navy. In May 1905, the U.S. Navy tested an improved Miller-Ligerwood rig using the Marcellus and a battleship Illinois near Cape Henry. These coaling tests achieved 35 mph while steaming at 7 knots, which still fell short of expectations. None of these coal systems ever approached the transfer rates required to make RAS practicable, considering that a battleship required over 2,000 tons and even a small destroyer required 200. It was only with the transition to oil as the main fuel for ships at sea that underway replenishment became genuinely practicable. Operational use. The first operational underway replenishment was achieved by the United States Navy Oil RUS Maumee. Following the declaration of war, the 6th of April 1917, she was assigned duty refueling at sea, the destroyers being sent to Britain. Stationed about 300 miles south of Greenland, Maumee was ready for the second group of U.S. ships to be sent as they closed her the 28th of May. With the fueling of those 6 destroyers, Maumee pioneered the Navy's underway refueling operations under the direction of Maumee's chief engineer Chester Nimitz, thus establishing a pattern of mobile logistics support which would enable the Navy to keep its fleets at sea for extended periods, with a far greater range independent of the availability of a friendly port. While during the interwar period most navies pursued the refueling of destroyers and other small vessels by either the alongside or astern method, it was the conventional wisdom that larger warships could neither be effectively refueled astern nor safely refueled alongside, until a series of tests conducted by now Rear Admiral Nimitz in 1939-40 perfected the rigs and ship handling which made the refueling of any size vessel practicable. This was used extensively as a logistics support technique in the Pacific theater of World War II, permitting U.S. carrier task forces to remain at sea indefinitely, since it allowed extended range and striking capability to naval task forces. The technique was classified so that enemy nations could not duplicate it. Presently, most underway replenishments for the United States Navy are handled by the Military Sealift Command. It is now used by most, if not all, blue water navies. Germany used specialized submarines to supply Hunter U-boats in the Atlantic during World War II. However, these were relatively ponderous, required both submarines to be stationary on the surface, took a long time to transfer stores, and needed to be in radio contact with the replenished boat, all conspiring to make them rather easy targets. Due to this, those not sunk were soon retired from the supply role. Although time and effort has been invested in perfecting underway replenishment procedures, they are still hazardous operations. Methods. There are several methods of performing an underway replenishment. Alongside connected replenishment. The alongside connected replenishment is a standard method of transferring liquids such as fuel and fresh water, along with ammunition and break bulk goods. The supplying ship holds a steady course and speed, generally between 12 and 16 knots. Moving that speed lessens relative motion due to wave action and allows better control of heading. The receiving ship then comes alongside the supplier at a distance of approximately 30 yards. A gun line, pneumatic line thrower, or shot line is fired from the supplier, which is used to pull across a messenger line. This line is used to pull across other equipment such as a distance line, phone line, and the transfer rig lines. As the command ship of the replenishment operation, the supply ship provides all lines and equipment needed for the transfer. Additionally, all commands are directed from the supply ship. Because of the relative position of the ships, it is possible for some ships to set up multiple transfer rigs, allowing for faster transfer of multiple types of stores. Additionally, many replenishment ships are set up to service two receivers at one time, with one being replenished on each side. In the U.S. Navy, aircraft carriers are always replenished from the port side of the supply ship. The design of an aircraft carrier, with its island navigation bridge to starboard, does not permit replenishment from the carrier's port side. Most other ships can receive replenishment from either side of the supply vessel. Alongside connected replenishment is a risky operation, as 2 or 3 ships running side by side at speed must hold to precisely the same course and speed for a long period of time. Moreover, the hydrodynamics of 2 ships running close together cause a suction between them. A slight steering error on the part of one of the ships could cause a collision, or part the transfer lines and fuel hoses. At a speed of 12 knots, a 1-degree variation in heading will produce a lateral speed of around 20 feet per minute. For this reason, experienced and qualified helmsmen are required during the replenishment, and the crew on the bridge must give their undivided attention to the ship's course and speed. The risk is increased when a replenishment ship is servicing 2 ships at once. In case of emergency, crews practice emergency breakaway procedures, where the ships will separate in less than optimal situations. Although the ships will be saved from collision, it is possible to lose stores, as the ships may not be able to finish the current transfer following successful completion of replenishment. Many U.S. ships engage in the custom of playing a signature tune over the replenished vessel's PA system as they break away from the supplying vessel. Astern fueling, the earliest type of replenishment, rarely used today, is astern fueling. In this method, the receiving ship follows directly behind the supplying ship. The fuel-supplying ship throws a marker buoy into the sea and the receiving ship takes station with it. Then the delivering ship trails a hose in the water that the fuel-receiving ship retrieves and connects to. This method is more limited, as only one transfer rig can be set up. However, it is safer, as a slight course error will not cause a collision. U.S. Navy experiments with Kuyama and Knorr led the Navy to conclude that the rate of fuel transfer was too slow to be useful, but the astern method of refueling was used by the German and Japanese navies during World War II, and this method was still used by the Soviet Navy for many decades thereafter. Vertical replenishment. A third type of underway replenishment is vertical replenishment. In this method, a helicopter lifts cargo from the supplying ship and lowers it to the receiving ship. The main advantage of this method is that the ships do not need to be close to each other, so there is little risk of collision. VERTREP is also used to supplement and speed stores transfer between ships conducting CONREP. However, the maximum load and transfer speeds are both limited by the capacity of the helicopter, and fuel and other liquids cannot be supplied via VERTREP. Gallery.